Been out since crack of dawn.
Would it be possible?
Hello, I'm Jeff Birchfield. Welcome to Quantum. Well, the world's full of them. Ageing civil engineering structures, roads, bridges, dams. Dams were the technological marvels of their day, but now they're not only showing signs of wear, they may be potential disasters. Cast your mind back a year or so to a scenic spot in the southeast of Australia.
That morning it was cool and sunny on top of the dam. Just the day to fix an annoying leak in the earth walls of the 60-year-old structure. This was to be a quick fix. They were pumping in liquid cement grout under pressure. The offending seepage lay somewhere around this concrete wall. The wall runs the entire length of the earth embankment and sits on bedrock 40 metres below. Somehow, water was getting past it. Barry Halpin was there that day. Just routine checking for any unexpected shifting of the wall. Like watching grass grow, he says.
It's a matter of sighting 4 fixed points protruding from the core wall. By reading it on that morning, we found that they'd moved approximately 4 millimetres. I know it's not very far, but it probably moves about that much in a 12-month period.
The day the earth moved, I was sitting here waiting for a story to come along, and along came a story.
Just 16 kilometres downstream lie the twin towns of Albury and Wodonga on the New South Wales-Victoria border. The 70,000 inhabitants greeted the prospect of a threatened 3 billion tonne tidal wave with, shall we say, interest.
Thought it was going to bust. We thought we'd all have to run to the hills to be safe.
50-year-old Hume, that carries 6 times as much water as Sydney Harbour, is cracking under the pressure.
We believe we must take an immediate action.
The dam no longer meets international safety standards.
It's always been on people's minds, I think, in this area, the dam bursting.
Half a metre of water has already been emptied from the dam.
Oh no, we're all going to die!
Downstream emergency service workers today met to plan their response.
The situation is safe.
It was all good media fodder. Furious farmers, flustered officials, compensation claims in the wind. The dam itself, the pride of the Murray-Darling Basin Commission, slipped somewhat into the background. But no mistaking, the old girl was showing ominous signs of age.
We don't believe it was in immediate danger of falling over, so I think that's the first important point to make.
The response to the issues at this dam are a symptom of ageing assets in Australia. Collectively, this dam was built in the early part of the century, and it was the 3rd largest dam on Earth when it was constructed.
And what a grand feat of engineering it was. 60 years ago, nothing came close to it in the entire British Empire, let alone Australia. Our engineers could build with the biggest. And they're still very proud of their dam in Albury-Wodonga. The equivalent of 6 Sydney harbours when it's chock full of winter rains and spring snowmelts from the distant snowies. But it's not a deep dam. When the levels drop, the skeletons surface. Depth was a problem the dam's designers had to grapple with. How to dam such a broad, shallow valley? The solution was, in effect, two dams, joined in the middle. Here, the concrete spillway, 330 metres long and 50 metres high, perched on the original bed of the Murray. Joined to the spillway, a long watertight concrete wall, the core wall, normally hidden by massive earth embankments. The embankment joins the spillway right on the New South Wales-Victorian border. Here, training walls stop the river swirling around and washing away the earth. It was the 1920s way of damming a broad valley, and it took 17 years to build. They got off to a good start in 1919. Fresh from World War I, returned soldiers put their trench digging tools to better use and co-opted the latest in steam technology. By the mid-1920s, the dam was already taking shape.
Because it gives you some concept of the construction of the thing. They'd started off from the New South Wales side, which is on the left, and they progressed across the river. The river in the early stages was running along the back of this area, and then it was coffer dammed to create a working area, and the river was then allowed to flow over the works that had been done prior to this. This was in August 1927.
It was a massive operation. Photos show the concrete core wall and its earth banks slowly creeping in from the Victorian side. They used horses to tread the earth down, and the wall was to stop water seeping through from the new lake. The core wall was to eventually meet up with the concrete spillway, the dam's centrepiece.
The construction of the dam was what they call cyclopean. It goes back to Roman times when they constructed the dams of rocks and stones cemented in. It is not a reinforced concrete dam. It's a gravity dam relying on its own weight.
The dam was completed in 1936.
That's why there's more cables sticking up than on the other.
The builders prudently provided future custodians with ways of accessing the dam wall's dark interior. There's about 30 metres of earth above what they call the blister gallery.
That was part of the original construction. The core wall was mass concrete, and the blister part, the curved section here is reinforced concrete. Immediately above us, against the core wall, is a drainage layer which permits any seepage to drain down the face of the core wall and escape through little weep holes, which there's one at our floor level here. Whatever seepage then might occur is run away into our gutter, which then drains into the river.
The Hume Dam became all its builders anticipated, and more. By the 1950s, the Murray's irrigation scheme had become fabulously successful. In their enthusiasm, the Hume's walls were made higher. A whole town disappeared under the rising waters of the expanding lake. But by the 80s, doubts were beginning to emerge. New ways of analysing forces on dams showed that gravity alone might not be enough to withstand the immense pressures of the increased storage. So, the spillway was tied down with precautionary cables. But were they up to the job? Every few years, these cables, more than 70 of them on the spillway, are checked. Workers perched precariously at the top.
There's a post tensioning cable consisting of about 54 strands going down about 100 metres into bedrock, and they put a head on top which is pre-tensioned to about 900 tonne. So we're just doing a regular check. This will be ongoing forever and a day. Make sure there's tension on the dam wall.
And so, with cables intact, the Hume Dam continued to weather the ebb and flow of flood and drought. The dam flexed and relaxed and occasionally shifted just a little. Towards the end of 1993, engineers became uncomfortably aware that a section of the dam called The Bend was quietly moving downstream, almost half a metre since the 60s.
It's an earth embankment, which is the earth embankment that gives the structural strength, the stability to the dam. And to stop the water from passing through the dam, there's this concrete core wall that passes from here right down into the foundations of the dam. And it's moving downstream with the embankment as well.
It had to be stopped, but how to do it? Strange machines began to test, probe and drill into the previously hidden layers of earth and fill.
It's a cone penetration test for pushing a probe. This is the similar probe. It's being pushed into the soil. The probe has inside it a number of transducers which record the end-bearing pressure on the tip as well as the sleeve friction on the sleeve. From these values you can determine the soil type that you're pushing through, and the computer will tell you whether you're going through sands, silts, clays, gravels or shells.
Engineers now had up-to-the-minute data to put into their equations. Their calculations showed that a new earthwork could slow the embankment's march downstream, so they set about doing just that. But their troubles were by no means over. The tired old dam was to make one more small step towards Albury-Wodonga and one giant headache for the engineers. It was all to do with a curious feature of the original construction: the tower. It was the first feature to emerge from the construction jumble. Its purpose was to link the concrete spillway and the core wall of the earth dam. The core wall was to slot into the tower like a mortise and tenon joint. They called it the key. It was designed to allow slight movement and was made watertight by coating the surfaces with bitumen. The slot photographed well. You can see it running all the way down the tower.
This is the key point of the whole construction. It's rather like any joint. It's the weakest point in the construction.
You can't see the tower now. It's been hidden by concrete for decades. But it's in there.
So here we have our tower block, and here is our core wall. The core wall keys into the tower block in a key which is 2 metres square, and it fits into the tower block in a manner similar to that.
But drilling teams working near the tower had made a horrifying discovery: wet earth on the wrong side of the tower. If it was a leak, then where was it coming from? Was water seeping around the junction? They thought of a stopgap, literally, plugging a possible leak temporarily by injecting liquid cement grout down into the junction itself.
One of the points you can see is this plastic tube where grout was injected, and the idea was that the grout would travel through that into the joint and downstream.
That's when it happened. A year's movement in a few minutes. A 4mm shift in the dam wall. Barry needed to confirm what he'd seen. He went straight down to the blister gallery, to an instrument of irrefutable truth, a plumb bob.
The plumb bobs, they're all fastened to the core wall, secured at a point at the top of the manhole, this particular one. And on the bottom side of it, if I lift that up, there's just a weight. And the weight is introduced into a thick fluid. This is liquid safe at this point to prevent or to minimise wind effect on the plummets. They're very delicate.
There was no disputing. In fact, it was worse. the wall had shifted by 5 millimetres.
The movement was more than we had expected. Yeah, to be fair to say that it caused us to have a rethink about and an immediate review of why that happened.
Leave was cancelled and rosters rewritten as routine monitoring was stepped up round the clock. Smaller movements continued. No one yet knew why. Meanwhile, the dam was filling rapidly with winter rains. Pressure on the wall increased. Engineers raced against time to pinpoint the problem around the tower. Had the core wall shifted in its slot? If so, computer models showed dangerous stresses on the downstream nib of the tower. They began to suspect the worst, that there was a crack somewhere in the tower or perhaps the core wall. And all this time the lake was rising, a store of water for the coming summer. What's more, upstream at the Dartmouth Dam, heavy rain was causing serious overflows. It was all heading for the Hume.
Southern training wall and the...
By October, engineers were convinced the dam was in trouble. A decision was made to open the floodgates. Low-lying farms were affected for hundreds of kilometres, all the way to South Australia.
All our pasture right through is just going to be all buggered. There's an element of sheer incompetence.
Why the devil they ever allowed the dam to fill to full capacity and now have to reduce instead of keeping it down, I just don't know.
What we did was resource the investigations as quickly as we could, and once those modelling results were completed, they confirmed a lower than acceptable factor of safety, and we responded to that immediately.
It took 5 weeks to let enough water out. It was a controversial decision. Was it the right one?
They were under a lot of pressure because you had another dam, almost 1.5 times larger, sitting up above it with a hell of a lot of water that was spilling. They had to do something, and that was the quickest and the most immediate thing.
Still under severe public criticism, the pressure was now on to verify the extent of any cracks in the dam structure. Holes were drilled in and around the tower. Cameras were inserted. Signs of cracking were unmistakable. Core samples confirmed the worst.
These boxes contain core taken from drill holes made in the tower block. There is a crack. This black substance you can see is bitumen from the original construction of the dam that was used to seal the slot. This hole is some 900 millimetres away from the slot, and over a period of time the movement of the core wall and the pressures on it have forced the bitumen to travel from the slot through to this point.
Almost half the tower was cracked. The nib, downstream of the joint, was looking very dodgy.
What's happened is that the core wall goes in like that, and as the core wall has been moving downstream, it's rotating like so, and that's putting pressure against the downstream part of the nib, and of course causing it to crack.
More ominously, the vertical drainage layer that takes seepage down to the drains below was missing from around the tower. Leaks had nowhere to go, and wet earth is weak earth. Their investigations had shown the Hume Dam gallantly holding back the waters of the lake despite cracked concrete and sodden earth. Now, with the facts fully before them, the Murray-Darling Basin Commission felt fully vindicated in their earlier emergency release. With renewed confidence, the pressure was now on to repair the dam. And before the winter rains arrived, a flurry of activity broke out all around the junction. Most important, the leak. The plan is to build a waterproof layer against the core wall to stop any water coming in at all. The installation will have to be carried out in a series of slots so that the wall won't weaken during the work. And this is the machine to do it, digging slots almost 50 metres down to bedrock for the waterproof membrane.
This is basically a purpose-made grad. It is self-plumbing. It's made for this trenching operation. It digs a long slot.
The slots are filled with a special concrete. It contains a remarkable natural clay called bentonite. When it sets, it's not only watertight, but flexible. If the embankment moves, it should hold tight. But just in case that doesn't work, they're going to put in that missing drainage layer on the downstream side of the wall. Large holes have been bored down to bedrock. They're being filled with a coarse type of sand, similar to what you'd find in a swimming pool filter. Now, any moisture that might seep through in the future will be safely conveyed down the sand and drained away. With the leak under control, they're now turning their attention to the earth walls.
Well, the aim of the exercise here is to provide extra stability to the embankment. And to do that, we're placing fill to add weight to the downstream toe of the embankment. But unfortunately, to be able to do that, we've got to do a number of other things, and the main one being we've got to stabilise the southern training wall here.
To hold that extra weight, the training wall is being strengthened by literally tying it down with huge steel cables.
It's just going down through this retaining wall, right through that, through all the rubble into the solid rock below, and that's where that's the proper anchor length, and then it gets stressed to hold this whole wall down onto the rock.
Once in place, the cables are fixed in with cement grout. As the training walls are strengthened, so a lot of earth is brought in for a new embankment. Meanwhile, at the base of the new embankment, a pile driver is hard at work ramming stones into the ground to form rigid columns. The stones will stop the river flat here giving way under the weight of the growing earth bank. It's a slow job.
Oh, roughly 10 a day. It all depends on the ground, you know. Altogether, 340. It's a very simple system, but it's very effective.
Now all that remains is the tower.
What we're going to do is drill a number of holes down into the tower block, some 30 metres deep, and we're going to install in those large diameter steel bars.
This is an important part of saving the dam, mending the cracks in the tower. This is the nib section, and these surveyors have highlighted the crack with yellow paint.
I think, yeah, you can see it there. It's probably better to find, just up out of the shadow, but that's down in through theirs.
It's a hairline crack here, but works its way down for 30 metres into the concrete. They're marking out where the drilling will be.
All of the yellow circles are the start of the hole, and then all of the different colour tapes specify the direction of the core hole, which orientation it should run off at.
Put it in the closest hole to us.
We can put it partially in the one we are going to do. Yeah, put them straight on the top.
Now the holes have been drilled, they're putting in the stainless steel bars. 36 of them, all at slight angles to the vertical. They'll be fixed in place by glue or cement grout, and the surface of the bars must be kept clean.
So we get a good contact between the actual grout and the bar itself.
Like stitches, the steel bars, firmly grouted in place, will stop the tower falling apart no matter what.
Radio, stop!
The relief is tangible. Disaster has been averted. As the dam now fills, new instrumentation will tell them if their efforts are all they'd hoped for. But they expect even at full capacity, the grand old lady will withstand even an earthquake.
We believe once those works are finished and other works that are programmed into the future, that the dam will be viable for the next 50 years at least, and probably 100 years.
These days, if a new dam were built, its embankment would be made from rock fill or earth compacted with heavy machinery, not horses. Properly drained, there'd be no need for a core wall. The sort of problem seen here would never arise.
Everything's fine now, we think.
I think it's good that they're doing something instead of just letting it go. Yeah.
Looks very good. Technically, I think they've got the answers now.
The panic button can be released now.
After all of this, after all the millions of dollars, you're going to have a dam that it's not going to leak, it's not going to move, and you can go up there on the summer weekends and go fishing.
We'll get off underpants. It's not my specialty.
Ruby Wax meets Sharon Stone. Coming up.